Well, hi everyone, this is Bob the Science Guy, and we're going to continue our history of the flat Earth. Now, many ancient civilizations had origin stories of the Earth based in mythology. For example, the one behind me is the Earth sitting on four elephants that are standing on the back of a turtle going through the universe, whatever that may be. But these origin stories were not based on scientific inquiry, they were based on religion and folklore. The first group that I'd like to talk about that actually systematically evaluated the Earth was the ancient Greeks. Now, one of the earliest references that I found was that of Pythagoras of geometry fame. He believed that the Earth was a sphere, but that was not based on any sort of actual observations. He believed that it was a sphere because a sphere is a perfect shape in his mind, and the gods would choose a perfect shape for the shape of the Earth. Now, long-distance observations began to be made on land, but most notably at sea. For example, it was noted that boats approaching a city would appear mast first, and then you would see the bottom of the boat as it got closer. Likewise, if the boat was moving away, it would disappear hull first. These gave some early clues as to the shape of the Earth. But Aristotle, in his book On the Heavens in 350 BC, made a couple of key observations. First of all, he understood that the lunar eclipse was caused by the shadow of the Earth. And when you looked at that shadow, it was always round, no matter where you observed it from. The only shape that would do that is a sphere, because a sphere from any angle appears to be a circle. And as you can see with this time lapse of a lunar eclipse, there is a very clear circular shadow eclipsing the moon in the middle. The other thing that he noted is when he looked at the stars in Egypt, there were stars in the southern sky that he could not see from Cyprus, 1,000 kilometers to the north. This is an extension of the reasoning used in the boat disappearing over the horizon. And from it, he gathered that the Earth was not only round, it was spherical, and it was not of infinite size, or else a mere 1,000 kilometers of distance would not make that much of a difference in the pattern of the stars. Next, we come to Eratosthenes about 100 years later. Eratosthenes was a mathematician and a geographer from Greece who was appointed director of the Library of Alexandria in about 250 BC. While there, he conducted his famous experiment to measure the size of the spherical Earth. He was not confirming that the Earth was a sphere. That was already very well accepted. He just was interested primarily in finding the size of that sphere, because his main interest was to create a map of the world. And to do that, he needed to know roughly the size of the world. And in his case, on a particular day, the sun was directly overhead of Cyrene, which is modern-day Aswan. And at that time, he measured the shadow of an obelisk in Alexandria and found that it formed an angle of approximately 7.4 degrees, or about 1/50th of 360 degrees. The distance between the two locations had been paced out to be 5,000 stadia, which is, a stadia is about 1/8 of a mile. So that's about 800 kilometers. Multiplying that 800 kilometers by 50, he gets approximately 40,000 kilometers, which is pretty accurate compared to the actual circumference of the Earth. Now, as I mentioned, Eratosthenes was a geographer, and his main interest was creating a map of the Earth. This is his map, and I find it rather interesting. You can identify a lot of different locations on this ancient map compared to the reality of our modern world. Here is Greece, here is Italy and Spain and the Strait of Gibraltar. Here is the Red Sea and the Persian Gulf. This is the Caspian Sea. But more importantly, look up here. This is a map from 250 BC, and Britain is here, and here is Ireland. So these were all known at the time of Eratosthenes based on these sea voyages that they were taking. The other interesting thing about this is that he has a concept of a meridian here. Notice in Alexandria, he believed that Cyrene was directly south of it along the same meridian. Likewise, we have this concept of latitude, or zona, where we have areas that are cold, we have areas that are temperate, and we have areas that are tropical. All in all, he did a pretty good job. Now, my favorite of the early Greek astronomers was undoubtedly Aristarchus of Samos. Now, while Aristotle supported the idea of a geocentric solar system, Aristarchus was an early proponent of the heliocentric universe, and the reason that he was he worked out geometrically the distances between the Earth, the Sun, the Moon, and the sizes of the Earth and the Moon. Now, the proofs for this are actually very fascinating, and I have two videos that I'm going to link in the description of this video that show how they were actually done. They are accurate. The reason that he got some incorrect answers when he did it in 200 BC was that his measurements were not as precise as they needed to be. I used his method to measure the distance from the Earth to the Sun, and I got within 1% or 2% of the actual distance. However, I was using a sextant, which is a precise measurement tool. He had access to nothing with that level of precision. Next, we come to Hipparchus of Nicaea. He is considered the founder of modern astronomy. Hipparchus of Nicaea made a couple of major contributions to astronomy. First of all, he cataloged the stars. These were the first true star maps. The other thing is he developed a magnitude scale, which is used with modifications to this day. But the thing that really made him an astronomer was that he didn't just map the sky. He actually looked into the records from Babylonia for the positions of stars, and he matched them up and found that they all shifted a couple of degrees. And from that, he correctly deduced that the Earth wobbled a little bit on its axis. So for example, in 13,000 AD, the North Star will be over here, but the North Celestial Pole will be up here. That's because this is a 26,000 year cycle. So when the pyramids were constructed in 3000 BC, the North Star was actually Thuban. Now, an interesting harbinger of things to come. He was well aware of the fact that Aristarchus was a proponent of a heliocentric solar system, and that he had come to that conclusion based on his calculation of the size of the Sun versus the size of the Earth. The Sun was 109 times larger than the Earth is. And his reasoning was that the Earth would orbit the larger of the two bodies. It makes no sense to have the larger of the two bodies orbit the Earth. And Hipparchus thought this was all good and fine. However, Aristotle felt that the Earth was geocentric, and that was in fashion at the time, so he kind of went with Aristotle. There wasn't really a good scientific reason for it, as there was a good scientific reason for Aristarchus to believe that the Earth was heliocentric. We'll see that with our next ancient astronomer as well, Ptolemy. Ptolemy was an astronomer that lived in the 1st century AD and developed an extensive concentric model of the geocentric solar system. He was the first to try and explain retrograde motion of the planets. So here's an example of what Ptolemy is talking about. We have a spherical Earth at the center of a geocentric solar system. The Sun orbits around the Earth. The planets also orbit around on their circles around the Earth. Now, you notice these small circles here. I believe they're called epicycles. But what these are put in for is the planets are assumed to actually orbit around these circles as they orbit around their main circle. This accounts for retrograde motion of the planets. Now, between Aristotle and Ptolemy, the geocentric universe held sway for more than 1,500 years, right up to the time of Galileo and Copernicus. And like Hipparchus, astronomers coming out with new ideas, especially heliocentric models, had to face the, well, that's not what we've always believed hurdle. But we'll talk about that in a video or two. In the next video, we're going to look at the onset of Christianity and early Christian beliefs on the shape of the Earth and the universe. So until then, this is Bob the Science Guy. Thank you for stopping by. Remember, just made another big payment on that telescope. If you'd like to participate in the telescope fund, we're looking to get delivery sometime in April or June. And that upgrade is going to be for a Celestron Edge HD 14-inch telescope. And that'll also have a hyperstar system on it, and it'll massively expand our capabilities out in the observatory. And that will, of course, be live streamed to the viewers over on the Shamrock Banks Observatory channel. So until next time, this is Bob the Science Guy. Take care.